Good morning. Welcome to this session. This session, we will solve an example problem on an inverted T section to find moment of inertia. Okay. So let us see the question. Calculate moment of inertia of an inverted T section, which is shown here. This is like inverted T shape about centroidal x axis. Okay. So your job is to first locate centroidal x axis. So where is this line? Okay. So for locating this centroidal x axis, you need to first take one reference line. So any line of your choice. So I go for the bottommost horizontal line as my reference line. Okay. So centroidal x axis to locate, you need to calculate y bar value of centroid. Okay. So this is the requirement, y bar. Okay. Yeah. Now divide this figure into two regular shapes. So I make it like this, two rectangles. So I call this as the rectangle 1 and this as rectangle 2. Okay, right. So now write the formula for centroid. It is A1 Y1 plus A2 Y2 by A1 plus A2. So this is the formula for centroid. Okay, right. Now write the properties of these A1 Y1 like A2 Y2. What are those values? So I'm going to write A1, which is area of the first figure. First figure is a rectangle which is having 900 length and 150 depth. So 900 by 150 is the area. And Y1 value. Y1 means what? The centroid of the first rectangle from this reference line. So from reference line, the centroid of first figure is here. So this distance is half of this 150. Okay, this is 150 by 2. Okay, 75 mm. All dimensions are in mm. Okay, yeah. Now, second area. This second area, you see this width of this stem here is 300. The depth of the stem is total depth 500 and this is 150. So this works out to 350 mm. So the area of that rectangle is 300 into 350. Then what is y2 value? The centroid of this second figure, okay, from the reference line, So this centroid, okay, of this figure will be half of this dimension. Okay, so this distance is y2. Okay, so this is from here to here, it is 150 plus this distance is half of this 150, sorry, 350. Okay, so 150 plus 350 by 2 is the y2 value. Okay, so this works out to 325 mm. Okay, so now these are the properties to be substituted to find y bar value. So y bar is A1 is 900 into 150 into y1 75 plus A2 300 350 into 325 divided by A1 900 into 150 plus 300 into 350. So this is y bar value and this works out to 184.375 mm. Okay. So the location of x axis, centroidal x axis of this figure is at a distance of 184.375 from this bottom horizontal line. So you have taken the reference as the bottommost horizontal line. From here, the centroid is located here. Okay, so this is our x bar line. Now for this, about this line, you want moment of inertia. Okay, so that is the next step. So now moment of inertia of this figure is equal to I about x bar line will be found by adding figure 1 moment of inertia about that centroidal line and figure 2 moment of inertia. Okay, so we need to add these two so that we will get this value. Yeah, let us find each individual I values. I x bar. Okay, you are not writing that as x line, so you are mentioning it as just x. Okay, yeah, so this is ix of the total figure is equal to, now first find ix of 1. Okay, so this I'll draw it aside here. So the rectangle, the first rectangle is 150 depth, 900 is the width. So this is a rectangle. For this, I need moment of inertia about this line. Okay, the overall x line is at a distance of 184.375 mm from bottom. Okay, from here it is 184.375. I want moment of inertia of this figure about this line. Okay, so we need to go for a parallel axis theorem. So now identify a parallel axis for this line passing through the centroid of the given figure. So this is the centroidal line, which we say x1, the first figure. So now your formula is Ix1 plus area into distance square. This is the parallel axis theorem. Okay, moment of inertia about a parallel line to the centroidal line is equal to moment of inertia about its own centroid plus area into distance square. Distance means distance between these two parallel lines. Okay, this distance is called d1. Okay, now write the properties. So moment of inertia of this rectangle about this its own centroid is bd cube by 12 plus a1 d1. What is b means the parallel dimension to the axis taken. The parallel dimension to this is 900 into d 150 cube by 12 plus, yeah, area 900 into 150. The distance square, distance between these two lines, you see, From bottom it is 184.375. So this distance is the centroid location, like 150 by 2. So I can write 154.375 minus 75 whole square. Okay. So that is the formula substitution. Yeah. So now the values you see 0. If you work out this, you get 0.253125 into 10 power 9 plus this term, second term, if you work out, it will be 1.61499 into 10 power 6. Okay, so put together, this value is 1.868 into 10 power 9. The units for moment of inertia is mm power 4. Okay, yeah, this is the first figure, moment of inertia. Okay, so going for the second one. Okay, yeah, Ixx of second figure is equal to, okay, yeah, draw the second figure here. It is 300 width, 350 depth. That is the second figure. Yeah, so the line or the overall centroid of the figure is like this. It is falling here. Okay, so from here, it is this distance is 34.375 because you see, yeah, you have a rectangle here. Okay, I'll just make it here. So this is your rectangle here. So from here it is 184. So if you deduct this 150, it will be 34.375. So this gap is 34.375 mm. Okay. Yeah. So this is overall centroidal line, XX line, what is asked for. Okay. Now the centroid of this own figure like rectangle is at 350 by 2, a midpoint of this figure. Okay, so this is x2 line. This is overall xx line. Okay, now this distance, what you call is d2. So now the formula will be Ixx of 2, the moment of inertia of this rectangle about its own centroidal axis plus area into distance square. Okay, so now write moment of inertia of the rectangle about its own centroid. It is BD cubed by 12 plus area into distance square. Okay, so the parallel axis theorem is going to involved be involved here. Okay, yeah. So substituting for these dimensions, so B parallel dimension, just look at here. This is the parallel dimension for this line. This is the parallel dimension. Okay, you are writing for this axis. Okay, moment of inertia. So 300 the opposite dimension by 12. Okay, plus area 300 into 350, and the distance is, so from here till bottom is half of 350. Okay, midpoint, that is 175 minus this distance 34.375. So from this distance, if you remove this one, you will get the remaining distance, that is this value whole square. Yeah, working out for these values, it is 3. Yeah, I'll write first individual values. 1.072 10 power 9 is the first value, plus 2.076 into 10 power 9 is the second value. So what we call this is a transfer term, okay? Because your moment of inertia about this line you want. So you know this value BD cube by 12. So to transfer moment of inertia from this axis to this axis, you need this transfer term that is called area into distance square. Okay. Yeah. So total put together 3.148 into 10 power 9 mm power 4. So this is for second figure. Okay. Yeah. Going with the total moment of inertia about the x bar line of the total figure. So it is 1.868 10 power 9 I1 value, 3.148 10 power 9 I2 value. So total it is 5.016 into 10 power 9 mm power 4 is the answer. Okay. Yeah, so carefully go through the each figure, and while you work out centroid, the reference line is most important to locate. Okay, it is of your choice from either the topmost line or the junction or the bottommost line. Anything can be of your choice. Okay, so and working out for moment of inertia, you need to write carefully this transfer term, properly mentioning these distances d1 and d2, and yeah, its own centroids, the very own centroids of the figures 1 and 2, okay, shall be properly written. Okay. Yeah, thank you. We'll be back with the next video.